This video shows both one-person and two-person alignment with all settings at default values. Refer to the installation guide for information on adjusting settings. With the system controller, receivers and transmitters installed, apply power and wait for the display to cycle through its test sequence, which takes about 3 seconds. The error code E02 will be displayed indicating that the system is not yet set up and we are ready to start commissioning. For other menu indications, refer to the installation guide. You will notice there is a locked padlock icon showing that the system controller is in the User menu. In this menu, settings can be reviewed, but changes cannot be made to settings or to alignment. To align the system, access the Engineering menu by entering the passcode using the keypad. The default is 1, 2, 3, 4. The padlock symbol will be unlocked, and you will now be in the Engineering menu. The next step is to find how many receivers are connected to the system controller. Access Find by highlighting the first icon on the left and pressing the tick button. To start the automatic Find sequence, press tick a second time. The display shows a countdown whilst finding receivers. If one receiver is connected, the countdown will take 10 seconds. If two receivers are connected, the countdown will exit as soon as both receivers are found. The receiver icon at the top left of the display shows which receivers have been found. The display also shows 2R to indicate the number of receivers found. Press tick to accept the found receivers and to return to the Engineering menu. If the number of receivers found is not correct, retry by pressing the cross button on the system controller and reselecting Find or refer to troubleshooting in the installation guide. The error code E05 means that the receivers have been found but are not aligned. With the correct number of receivers found, we can commence alignment. The following stages are carried out for each receiver and transmitter pair in turn. You can select between receivers by toggling the up and down keys whilst in the Engineering menu. We will first align receiver 1. Notice how the receiver icon identifies which receiver is selected. The first stage of alignment is to align the receiver onto the transmitter using the integrated laser in the receiver. To activate the laser, select the second icon. The display now shows how many minutes the flashing laser will remain on for. This can be changed if required. Press tick to accept the number of minutes and turn on the laser. Whenever the laser is on, the system will be in fault. The laser can also be turned on by using the laser switch on the receiver head whilst in the Engineering menu. We are going to use the thumb wheels to steer the laser in the receiver towards the transmitter. The laser is low-powered and flashes only once per second. However, it is a sensible precaution to avoid looking directly into it. It is not essential to steer the laser perfectly onto the transmitter. Within 15 centimeters is all that is required. If you cannot see the laser, refer to troubleshooting. Now that the receiver is correctly aligned, press the laser switch on the receiver or press cross on the system controller to turn the laser off and exit to the Engineering menu. With the receiver aligned, we can start the alignment of the transmitter. At the system controller, select the third icon. ALN will be shown on the display. Press tick to enter alignment mode. The number shown on the LCD is the alignment value. Alignment can be completed by one person using the alignment LEDs on the receiver, or two people by referring to the alignment value on the LCD of the system controller. For two-person alignment, one person will need to stay at the system controller to communicate the alignment value to the person at the transmitter. Alignment is achieved by adjusting the transmitter direction and, if necessary, the transmitter power. During alignment, ensure that the beam path is kept clear. At the transmitter, ensure that the transmit power is at maximum. The transmitter power is adjusted by gently turning the single-turn potentiometer. For one-person alignment, look back towards the receiver to view the alignment LEDs. For two-person alignment, refer to the alignment value on the LCD. In this state, there are three possibilities. The first possibility is that the LEDs flash green, with alternating short and long flashes. In this case, the received signal is too high, and the receiver is saturated. This is indicated on the LCD as a value of 180. Reduce the transmit power by turning the potentiometer anti-clockwise until the flashing stops. The amber LED may flash to show that the signal is dropping, followed by no LED flashes. The alignment value on the LCD will also decrease. If possible, reduce the transmit power so that the alignment value is around 100. The second possibility is that the LEDs flash amber, with alternating short and long flashes. In this case, the receiver is not seeing any signal from the transmitter. This is indicated on the LCD as a value of 0. Adjust the transmitter thumb wheels to better align the transmitter onto the receiver until the flashing amber LED goes out. The green LED may flash to show the signal has increased, followed by no LED flashes. The LCD will show a value of between 2 and 178. The third possibility is that there are rapid green flashes, followed by no LEDs flashing. The LCD will show a value of between 2 and 178. It is when in this state that the receiver is seeing enough transmitted signal to allow further alignment. During this stage of alignment, the transmitter will be adjusted so that it is centered onto the receiver. Whilst looking at the receiver alignment LEDs, or alignment value, select one thumb wheel and rotate it 1/4 of a turn and let go. Amber flashes on the receiver indicate the signal is reducing and the movement was in the wrong direction. There will be a corresponding decrease of the alignment value on the LCD. The same thumb wheel should be rotated by 1/4 of a turn in the opposite direction to achieve a green flash and an increase in alignment value on the LCD. Green flashes indicate that the signal received is increasing and that the transmitter movement is in the correct direction. There will be a corresponding increase of the alignment value on the LCD. Wait until the green LED has stopped flashing or the alignment value on the LCD is stabilized before making further adjustments. Continue by making further quarter turns in the same direction, letting go of the thumb wheel and observing the alignment LEDs or LCD value each time. If the LED flashes green or if the LCD value increases, continue in the same direction as the signal is increasing, remembering to allow the LED to go out or the LCD alignment value to stabilize each time. As the transmitter alignment is improved by moving the thumb wheels, it is possible that the receiver can become saturated, as indicated by alternating short and long green LED flashes, and an alignment value of 180 on the LCD. If this occurs, reduce the transmit power by turning the potentiometer anti-clockwise until the green LED goes out, or so that the alignment value drops to around 100. Do not adjust it so that the amber LED flashes with alternating short and long pulses, or the LCD drops to 0, indicating that the receiver is no longer seeing the transmitter. Continue with the alignment on the same thumb wheel in the same direction. When the LED flashes amber, or the alignment value starts to decrease, the transmitter has been moved past the point of best alignment in that axis. Rotate back 1/8 of a turn, or so that the LCD alignment value returns to its highest seen value. Alignment in this axis is completed. Now adjust the other thumb wheel using the same steps as for the first thumb wheel. With alignment completed, return to the system controller and press Tick to accept the alignment and return to the engineering menu. The system controller indication LED and relay pair corresponding to this receiver will now be in normal operation mode. If two receivers are connected to the system controller, repeat the alignment process after having selected the second receiver. The green LED on the system controller will flash every 10 seconds to indicate the system is operating. When a receiver is in fault, the corresponding LED on the system controller will flash amber every 10 seconds. Similarly, when in fire, the red LED on the receiver and the corresponding LED on the system controller will flash red every 10 seconds. Now it is time to conduct a fire and fault test to confirm correct commissioning. A remote fire test is performed by selecting the remote fire test icon, third from right. Press Tick once to test the fire LED on the underside of the receiver. A second tick will simulate a fire condition in order to test the relay and wiring back to the fire panel. The display will show fire, and the fire control panel should indicate a fire condition. The system controller LED corresponding to the receiver under test will flash red. Press the cross button to end the test and return to normal operation. To perform the fault test, completely cover the receiver using non-reflective material, taking less than 2 seconds to do so. After the delay to fault time, the system controller indication LED and relay pair corresponding to this receiver will now be in a fault condition. Uncover the receiver to return the system to normal operation. To perform a manual fire test, slowly cover half the receiver using non-reflective material, taking more than 2 seconds to do so. After the delay to fire time, the system controller indication LED and relay pair corresponding to this receiver will now be in a fire condition. Uncover the receiver to return the system to normal operation. Commissioning is now complete. There are further settings that can be made. For example, the fire threshold can be set for each detector. The delay to fire and fault can be set for each detector. The system mode can be set to latching or non-latching. Refer to user guide for further instructions. Please refer to the user guide and CD included with the product for further information. Hello. I'd like to show you how to properly commission an optical beam smoke detector. The settings are given in the installation guide as well as on the back label of the beam detector. On the back of the beam detector are the dip switches and the mode switch. Choose the settings that you need. Factory default is switches 1 and 4 up and switches 2 and 3 down. The commissioning can be done with the front cover fitted or removed. With the beam powered and reflectors installed, move the mode switch to the up position, which is reflector targeting mode. In reflector targeting mode, you are trying to find the reflector by steering the beam detector with the vertical and horizontal thumb wheels. The faster the amber LED flashes, the stronger the signal back from the reflector. Steer the beam detector to get a solid amber LED. Once you have the solid amber LED, confirm you are actually on the reflector and not on another object by covering up the reflector and checking the amber LED goes out. Now, move the mode switch to the middle position, which is alignment mode. In alignment mode, you are centering the beam detector on the reflector and the beam detector is adjusting its power for optimum signal. The LEDs now mean something different. A red LED means that you are gaining signal, and an amber LED means that you are losing signal. Choose a thumb wheel. It doesn't matter which one you choose first. We are going to adjust both of them. Turn half a turn. If you get the amber LED, stop. You are going the wrong direction. Turn back a half turn and you get the red LED. Wait and let the red LED go out. While the red LED is flashing, the system is reducing its transmit power. Wait for the red LED to go out. Initially, it can take up to 1.5 minutes for the LED to go out. The closer you get to the center of the reflector, the sooner the red LED will go out. Turn the thumb wheel half a turn in the same direction. Wait for the red LED to go out. Do it again. It can take up to 20 to 25 turns. Keep chasing the red LED until a turn gives no LED. Turn the thumb wheel further half turns in the same direction until the amber LED flashes. This means you have gone past the center of the reflector. Come back half a turn. Repeat this process for the other thumb wheel. We are ready to move the mode switch down into the operation mode. The beam detector makes final internal adjustments and saves its settings. You must stay out of the beam path during this time. You will hear the fault relay click in and the LEDs will flicker for a little bit. You now have a working system. You can check the beam detector is centered on the reflector just by touching each edge, then the top and bottom of the detector head. When you touch each side of the detector head, there will be a short flash of the amber LED to indicate beam is slightly off center of reflector, and when released, no LED lights to indicate beam is centered on reflector. Now we want to do the fire and fault test. For the fire test, find the fire threshold value on the supplied test filter. Factory default is 35%. Slowly cover the top lens to this value and wait for a short delay of approximately 10 seconds. Fire should be signaled with a solid red LED, and you will hear the fire relay click in. Once you remove the filter, the beam detector will reset automatically after 5 seconds. For the fault test, fully cover the reflector rapidly and wait for a short delay of approximately 10 seconds. Fault should be signaled with a solid amber LED, and you will hear the fault relay click in. Once you remove your cover, the beam detector will automatically clear. Refit the front cover if previously removed. Commissioning is now complete. Hello. I'd like to show you how to commission a multi-head optical beam smoke detector. With the beam detector and reflector installed, apply power. All the segments light up for a short period. Then E01 is displayed almost immediately after that. Wait for the display to show E02. Power-up can take about 45 seconds. E02 indicates the detector is operating but that the system is not yet set up. The LED indicator on the upper right of the system controller flashes green every 10 seconds to indicate normal operation. Enter the passcode using the keypad. Default is 1, 2, 3, 4. This takes you to the engineering menu. For a system that's not yet set up, the command find will be displayed. Press the tick button to start the find command. This interrogates the system to see how many detector heads are connected. The display will count down from 60. After 60 seconds, the number of detector heads found will be displayed, 1D or 2D. Press tick to accept if the number is correct. We are now going to align each detector head in turn. Now select the detector to be set up, and this can be done anywhere in the engineering menu by pressing the up and down keys. Once the detector has been selected, go back to the detector menu to begin the alignment of that detector. Having moved to the detector menu, the next thing to do is to select the range, which is the distance between the detector and the reflector. Select from 8 to 50 meter or 50 to 100 meter ranges. Now turn on the laser by selecting the laser icon on the engineering menu. The system will be in fault during laser alignment. Use the arrow keys on the system controller to steer the laser until it falls on the reflector. Once this is done, select either the tick or cross button to turn off the laser. You are now ready to perform automatic alignment of the chosen detector. In the alignment menu, there are two options: Hand and Auto. Hand is only used by advanced users in troubleshooting, so select Auto from the alignment menu and press Tick. The auto alignment will take approximately 3 minutes, during which detector signal strength can be viewed on the display. This procedure ensures the best alignment and detector power for the installation. If the system detects a problem, an error code is displayed on the LCD. Refer to the user guide for error codes. When finished, Set will be displayed. The Set procedure ensures we are aligned to the reflector and adjusts for any background noise in the system. With Set displayed, press Tick once. S00 will be displayed. Completely cover the reflector with a non-reflective material. Whilst covered, press Tick once more and S01 will be displayed. Uncover the reflector and press Tick once more. It is now possible to select another detector and repeat the range, laser, auto, and set sequence. In normal operation, the detector LED will flash green. In fault, the detector LED will flash amber, and the LED on the system controller corresponding to the detector head will also flash amber. Similarly, in fire, the detector LED and LED on the system controller corresponding to the detector head will flash red, and if the LCD was in sleep mode, then fire will also be shown. There are other settings that can be made. For example, the fire threshold can be set for each detector. The delay to fire can be set for each detector. The delay to fault can be set for each detector. The mode for the system can be set to latching or non-latching. Refer to user guide for further instructions. Now it is time to conduct the fire and fault tests to confirm correct commissioning. For the fire test, using a non-reflective material, slowly cover the reflector, taking longer than 2 seconds. After the delay to fire time, fire will be signaled. An alternative fire test can be performed from the Fire Test menu. Select the Fire Test icon in the Engineering menu. Press Tick twice. The system reports a fire to the Fire panel. Press Cross button to stop the fire test and return to the Engineering menu. For the fault test, using a non-reflective material, completely cover the reflector within 2 seconds. After the delay to fault time, a fault will be signaled. Commissioning is now complete. Please refer to the user guide and CD included with the product for further information.